goes along with section 1.1.6 from the CPM book, and it's about a lot of different little things, and um, a lot of these things are just things that I would normally correct during the Algebra 2 portion of this class, but since they're a little bit condensed, and I know there's a little bit of frustration out there that we're squeezing a lot of different things into a shorter amount of time, and I'm going to ask you to just bear with it, and also just remind you that one of the standards of mathematical practice has to do with persevering through challenging problems. I can't remember exactly how it's worded, but I know it has the word persevere in it, and a lot of math in general, and this year specifically, is going to be involving persevering when things get difficult. So I encourage you to keep your head up and do the best you can and ask questions when you have them. So one problem that I saw today has to do with when you have, let's say, an expression like x plus 5 divided by x minus 7. And a lot of people want to cancel out the x's like that. And let's see, if I'm doing that, then that would be saying that x plus 5 over x minus 7 is equal to 5 over negative 7. One way I could check to see if that's a legal maneuver in mathematics is just picking a number. So I'm going to pick number 3. And let's say if I put in 3, am I going to get that same value? And in this case, no, I'm not, because I'd get 8 over negative 4. So this is not okay. I don't want you to do it, even though a lot of people are inclined to do it. It's a mistake. You can't do it. What you're doing is you're canceling terms. When things are listed as plus x squared plus x minus 7, these are terms. They're terms because they're separated with a plus and a minus sign, okay? You cannot cancel terms. What you can cancel are factors. Factors are things that are written as multiplication. So if I have like 3 times 4 times 7 divided by 4 times 6 times 5, what you know is that you can cancel these 4's, right? And then you also know that you can cancel things that have a common factor. So like I could cancel the 3 and the 6 and put a 2 there, and this would be 7 over 10. So it is okay to cancel factors. That's good. And factors are separated by multiplication, okay? So the rule that you have to remember is you can cancel factors and you should never cancel terms. And so there was a problem that was like, well, in 1.1.6, you were trying to find equivalent expressions, and an expression is different than an equation. An equation might be x plus 2 equals 5. This is an equation. It's an equation because it has an equals sign. And with an equation, I can do certain things, like I could multiply both sides of the equation by 3, and I could get a whole new equation like 3x plus 6 equals 15, and this would still be true because I've multiplied both sides of the equation by 3, by the same number. In an expression, I might have just a rule, something like x plus 2. I could plug in 100 or even 1,000 different x's in there, and they would all give me different numbers. If I multiply this expression by 3, I get 3x plus 6, and that gives me a new expression. And those are not, the original expression, x plus 2, does not equal that 3x plus 6. So it is not a legal maneuver when trying to identify equivalent expressions to just multiply by something. What I can do is I can multiply by something like 3 over 3. And the reason I can multiply by something like 3 over 3 is because that equals 1. And it's okay to multiply by something by 1 because 1 isn't going to change the value of the expression. It just changes how it looks. And in this case, it doesn't make it look any prettier. I would get 3 over 3x plus 2 times 3 over 3. But it does make it look different. Okay, so a legal maneuver when trying to identify equivalent expressions is to multiply by something that's equal to 1, but it's not. But multiplying by anything other than that is illegal. So there was one where you had 6x plus 1 plus 5 over x minus 1. And I told you one thing that you could do, like if you had 12 plus 3 over 7 and you wanted to put these together, you'd multiply this by 7 over 7, you'd get a common denominator. You can do the same thing with algebraic expressions. In this case, what you'd be doing is multiplying just the left side by x minus 1. And remember, there's like an imaginary 1 underneath that fraction, so I'd multiply this by this, and to do that, I'd have to use a process called FOIL. So I'd multiply the firsts, and I'd get 6x squared, and then I'd multiply x by 1, so plus x, then the insides, which would be negative 1 and 6x, so I get negative 6x minus 1, and that would all be over x minus 1, and then I get plus 5 over x minus 1. And now I have 6x squared plus minus 5x minus 1 plus 5 divided by x minus 1. And these two terms, the minus 1 and the plus 5, are like terms, so I can put those together. So I'm going to get plus 4. And in math, there's no such thing as one-way streets. There's always streets that you can go in one direction and you can go the other. This is a little shortcut that might be a little more intuitive for you to get from the expression that I started with 6x plus 1 plus 5 over x minus 1, to get from this location to this location. But the more straightforward path that you might take would be using a process called polynomial division, which you may have done a little bit in Algebra 1, but it's probably a process that doesn't come back like riding a bicycle as easily. Although it does, if you think of, say I have 21 divided by 9, and I wanted to turn that into a mixed number, I'd go 9 goes into 21, and I would say 9 goes into 18 2 times. 2 times 9 is 18, and then I'd subtract and I'd get 3, and so I'd get 3 over 9. So this is equal to 2 and 1 over 3. And polynomial division, the process works the same as it does in long division. So I'm going to put x. It works the same. It's just more confusing because there's more variables in there. And in chapter 3 of this book, we have a couple sections on polynomial division. So you don't have to be an expert at this now, but I think you should know that it's out there and it's a process. And if you're intrigued to know the ins and outs and what have yous of it, you can look it up on Khan Academy or anywhere else on the internet and find more about it. But I need to multiply x by something to get 6x. So x times 6x is going to give me 6x squared. So now I'm going to take this 6x and I'm going to multiply it by this whole expression. And I'm going to get 6x squared minus 6x. And now I'm going to subtract it, but I'm subtracting this whole expression. Okay, and when you're subtracting a whole expression, you have to distribute the minus sign into both terms. So this is going to be a minus and a plus. And so now I get those two terms cancel, and I get plus 1x. Now the plus 4 is going to drop down. Now I'm thinking this x, and I'm looking at this x, how many times, what do I have to multiply x by to get to x? And that's 1, so I'm going to get a plus 1. Then I'm going to multiply this 1 down into this whole expression, which is just going to give me an x minus 1. Now I'm going to subtract this whole quantity, which for me it's easier to just change the sign on every single term, and then those cancel, and I get 5. And so this is going to be plus 5, but the 5 is the remainder, and so the remainder you have to put as the numerator of the fractional part, okay? And so this process is going to be important when we do rational functions. It's helpful to notice that the 5 is the part that has a denominator, and it's also helpful to know that this expression right here is the same one that we started with right here. So there was another thing that we talked about, substitution. And this is also another thing that we'll come back to throughout the year, but it helps sometimes when factoring, when you get something where you can just sense that there's something that you can factor, but you just can't put your finger on how to do it yet. Like in this case, you see that there's an x minus 1 in both of, you could think of this as, we talked about terms and factors, you could think of this as 3 separate terms, this problem right here. So we're trying to factor it, okay? And you can see that in the first 2 terms, they have a common x minus 1. And so you might just think, let's play around a little bit. Let's take a new letter, why not u? And I'm going to make u equal to x minus 1. And if I substitute u in for x minus 1, then I'm going to get u squared minus 7u plus 12. And now this looks like something that I can work with. This right here looks like something that I can work with because it's a trinomial. And with the trinomials, everybody learns their own way, but the way a lot of people seem to learn is to make this big X, and you put the negative 7 in the top, and you put the positive 12 in the bottom, or maybe some people invert that and put the 12 in the top and the negative 7 in the bottom. The important thing is that 2 numbers multiply to this number 12 and add to negative 7, okay? So I need 2 numbers that multiply to 12, which is 3 and 4, and if they're going to add to negative 7, they're both going to be negative. So this is going to be u minus 3 times u minus 4. And a lot of times people will be like, all right, that's cool, I'm done, and then move on to the next problem. But you can't do that because you made a substitution back up here, and you need to go back and you need to plug in this expression that we started with for your final answer. So if I'm plugging x minus 1 back in for u, I'm going to get x minus 1 minus 3 times x minus 1 minus 4, which is going to be x minus 4 times x minus 5. And then that's your answer. That's your simplified form of it. And there was another one that said x minus 1 to the 3/2 plus x minus 1 to the 1/2. And I think I explained this a little bit better in one class than the other, but there's so much in this that it's worth taking a breath and slowing down for a second and remembering, what does that 1/2 mean? Well, that 1/2, if I say 16 to the 1/2, that means the square root of 16, which is, in this case, 4. So what does the 3/2 mean? If I say let's say 8 to the 3 halves, what does that mean? That means 8 cubed to the 1 half. Or it could mean, well, let's pick a different number. Let's pick 4. 4. That means 4 cubed to the 1 half. So 4 cubed, or it could mean 4 to the 1 half cubed. 4 cubed to the 1 half, 4 cubed is 64. The square root of 64 is 8. 4 to the 1 half is 2. 2 cubed is 8. So either way I do it, it should leave me in the same place. What is, it is helpful to point out at this point, if I have a to the 2 halves, let's just do this. So a to the 3rd plus a to the 5th. Does that equal a to the 8th? No. Hopefully everybody's thinking no, or even some of you might even be thinking hell no or something like that. But a to the 3rd times a to the 5th is equal to a to the 8th. So when you multiply two factors that have the same base, you can add the exponents, not when you add them together. But so I could think of x minus 1 to the power of 1 times x minus 1 to the power of 1 half. And what would that, or if I said a to the power of 1 times a to the power of 1 half, that would be a to the 1.5, which is still the same thing as saying a to the 3 halves. So if I say x to the minus 1 to the 1 times x minus 1 to the 1 half, that could be x minus 1 to the 3 halves. And so if I want to rewrite this in a different way, I could say x minus 1 times x minus 1 to the 1 half plus x minus 1 to the 1 half. And if I didn't like fractional exponents, I could say x minus 1 to the square root of x minus 1 plus the square root of x minus 1. And if I wanted to stick with the topic that was given, which is substitution, I might notice that we've got right here and right here a similar expression. And so let's say I have, let's use u. Let's make u equal to the square root of x minus 1. Let's see if we can simplify this a little bit. So now I could call this x minus 1 times u plus u. And if I wanted to factor out, well, I could say this is x u plus u, xu minus u plus u. And that would mean xu, and I'd have to go back and take this and substitute it in there. And so that would be x times the square root of x minus 1. Alternatively, if at this point you wanted to just say this has x minus 1 to the 1 half as a common factor, what's left, I'm going to have to multiply this by two things, and it's going to have to take me back to this expression. You could think, well, this is going to have to be x minus 1, and this is going to have to be 1. And this could be then x minus 1 to the 1 half times x, which gives me the same answer, x times the square root of x minus 1.